Today, we're going to work through the solutions for the Cambridge IGCSE Mathematics Specimen, Paper 2, which is the non-calculator extended paper. In this lesson, we have three main learning objectives. First, to apply arithmetic and geometric principles without a calculator. Second, to solve algebraic and trigonometric problems step by step. And finally, to identify and avoid common examination pitfalls. Our goal is to cover each question clearly, ensuring you understand the logic behind the math and the specific traps to look out for in a non-calculator environment. Remember, all your working must be shown to secure full marks. Let's start with the first two questions, which focus on decimals and significant figures. For question 1, we need to calculate 0.01 squared. When squaring a decimal, remember that the number of decimal places in the answer is the sum of the decimal places in the numbers being multiplied. Since 0.01 has 2 decimal places, our result must have 4. 1 times 1 is 1, so we place the 1 in the 4th decimal position. A common mistake is to only double the decimal places to 2, resulting in 0.01 again, or 0.1. Always count the total places. Question 2 asks for 57.3997 to 4 significant figures. Starting from the first non-zero digit, the first 4 figures are 5, 7, 3, and 9. We look at the 5th figure to decide whether to round up. Since it is a 9, we must round the 4th figure up. Rounding the 9 up carries over to the 3. So, the answer is 57.40. Notice I included the 0 at the end. In significant figures, that trailing 0 is essential to show the level of precision required. Moving on to questions 3 and 4, involving currency conversion and geometry. For question 3, IME changes €250 into dollars. Since €1 is worth $1.10, we multiply the amount by the exchange rate. To do this without a calculator, think of 1.10 as 1 plus 0.1. 250 times 1 is 250. 250 times 0.1 is 25. Adding them together, 250 plus 25 equals 275. So, IME receives $275. A common mistake here is dividing by the rate instead of multiplying. Always check if your answer makes sense. Since the dollar is worth slightly less than the euro here, you should end up with more units of currency. Question 4 provides a diagram with two triangles, ABD and ADC. We are told AB equals AC, which makes triangle ABC an isosceles triangle. Because the base angles of an isosceles triangle are equal, angle ACB is also 61 degrees. Now look at triangle ADC. We know two angles. The angle at C is 61 degrees, and the angle at D is 81 degrees. Subtracting these from 180 gives us the remaining angle. 81 plus 61 is 142. 180 to 140, 2 is 38. The final answer is 38 degrees. Students often miss the isosceles property of the large triangle, so always look for those tick marks on the lines. Now let's tackle questions 5 and 6, which involve unit conversions and density. Question 5. Convert 0.17 meters squared into centimeters squared. In question 5, we need to convert an area. A very common mistake is to assume that because there are 100 centimeters in a meter, you just multiply by 100. 1 meter equals 100 centimeters. 1 meter squared equals 100 centimeters times 100 centimeters. 1 meter squared equals 10,000 centimeters squared. However, for area, you must square the conversion factor. 1 square meter is actually 10,000 square centimeters, 0.17 times 10,000. So, we move the decimal point 4 places to the right. Answer: 1,700 centimeters squared. Always remember to square the linear conversion factor when dealing with area. Question 6. Calculate density in grams per centimeter cubed. Question 6 asks for the density of a cuboid. We are given the mass as 4 kilograms and the volume as 600 cubic centimeters. The question asks for the answer in grams per cubic centimeter, so first we must convert the mass. 4 kilograms is 4,000 grams. Density equals mass divided by volume. Density equals 4,000 divided by 600. We can simplify this fraction by dividing both the numerator and denominator by 100. This further simplifies to 20 over 3. Answer: 6 2/3 grams per centimeter cubed. As a mixed number, that is 6 2/3 or 6.67 if rounded. Leaving it as 20 over 3 or 6 2/3 is usually safer in a non-calculator paper. For question 7, we are working with vectors. We have vector u as 3, -2, and vector v as -12, 5. In part A, we need to calculate u minus 2v. We start by multiplying vector v by the scalar 2. Now we subtract this from vector u. Be very careful with your signs here, as subtracting a negative is a very common place to lose marks. 3 plus 20, 4 is 27, -2 to 10 is -12. The resulting vector is 27, -12. In part B, we find the magnitude or the modulus of vector v. This is essentially using Pythagoras' theorem on the components. Remember that squaring a negative number always results in a positive number. -12 squared is 144. 5 squared is 25, 144 plus 25 is 169. The square root of 169 is 13. The magnitude is 13. If you find yourself trying to take the square root of a negative number, you've likely made a sign error when squaring the components. Let's look at questions 8 and 9, which cover geometry and sequences. Question 8 asks for the total perimeter of a semicircle. The perimeter consists of two parts, the curved arc and the straight diameter. The circumference of a full circle is pi times diameter. For a semicircle, the arc is half of that. The arc is 1/2 times pi times 9, which equals 4.5 pi. The total perimeter is 4.5 pi plus 9. The question asks for the exact form, so we do not use a decimal approximation for pi. The answer is 4.5 pi plus 9 centimeters. A common mistake is forgetting to add the 9 centimeter diameter at the end, only calculating the curved part. For question 9, we have a sequence. Let's look at the difference between terms. 17 to 12 is -5. 12 to 7 is -5. This is an arithmetic sequence with a common difference of -5. To find the fifth term, we subtract 5 from 2, giving us -3. For the general rule, we use the formula for an arithmetic sequence, a plus n minus 1 times d. T of n equals 17 plus n minus 1 times -5. This simplifies to 17 to 5n plus 5. The final answer is T of n equals 22 minus 5n. Alternatively, since the difference is -5, the rule starts with -5n. If n equals 1, -5 times 1 is -5. To get to 17, we need to add 22. Moving on to pages 6 and 7, we have fractions, indices, and standard form. For question 10, we need to add mixed numbers. It's usually easiest to convert them to improper fractions first. 2 and 2/3 equals 8 over 3. 3 1/2 equals 7 over 2. Now we need a common denominator, which is 6. 16 plus 20, 1 equals 37, so 37 over 6. The question asks for a mixed number in its simplest form. 37 divided by 6 is 6 with a remainder of 1. In question 11, we deal with a fractional index. Remember the rule, the denominator is the root and the numerator is the power. 64 to the power of 2 over 3 equals the cube root of 64, squared. The cube root of 64 is 4, because 4 times 4 times 4 is 64. 4 squared is 16. For standard form multiplication, multiply the numbers and add the powers of 10. 7.1 times 2 is 14.2. -15 plus 3 equals -12. This gives us 14.2 times 10 to the -12. To keep it in standard form, the first number must be between 1 and 10. For addition, the powers must be the same. Let's change the first term. 52 times 10 to the 6 plus 5.2 times 10 to the 6 equals 57.2 times 10 to the 6. Converting back to standard form gives us 5.72 times 10 to the 7. A common mistake is adding the exponents during addition. Remember, that only applies to multiplication. Next, we look at polygons and statistics on page 7. In question 13, we need the number of sides, which we call n. The easiest way to solve this is using the exterior angle. Since the interior and exterior angles on a straight line sum to 180 degrees, the exterior angle is 18 degrees. The number of sides, n equals 360, divided by the exterior angle. 360 divided by 18 is 20. The polygon has 20 sides. A common mistake is trying to use the interior angle formula, 180 times n minus 2 all over n, which involves much harder algebra. The exterior angle method is almost always faster. Question 14 is a logic puzzle. We have 5 numbers. Let's list them in order: A, B, C, D, E. Since the median is 10, the third number is 10. For the mode to be 10, at least 2 numbers must be 10. Let's try making B or D equal to 10 as well. The range is 10, so E minus A equals 10. The mean is 10, so the sum of the 5 numbers must be 50. If we have a set like 5, 10, 10, 10, 15, the sum is 5 plus 10 plus 10 plus 10 plus 15, which is 50. The range is 15 minus 5, which is 10. This set works perfectly. All 5 conditions are met. There are other possible sets, but this is the most straightforward one. For question 15, we need to describe the single transformation that maps triangle T onto triangle A. Notice that triangle T is laying down while triangle A is standing up. This suggests a rotation. Triangle T has vertices at 1, 1, 4, 1, and 4, 2. Triangle A has vertices at 2, 3, 2, 6, and 3, 3. If we rotate T by 90 degrees anti-clockwise, the horizontal base becomes a vertical side. To find the center, we can use the perpendicular bisectors of the lines connecting corresponding points, or use trial and error with tracing paper. Let's test the origin. 0, 0. Point 4, 1, rotated 90 degrees anti-clockwise about 0. 0 becomes negative. 1, 4. This does not match. The final correct description for this specific graph is a rotation 90 degrees anti-clockwise about the center 1, 4. Make sure to include all 3 parts: the type of transformation, the angle and direction, and the center point. Missing one of these will cost marks. A common mistake is forgetting the center of rotation or getting the direction wrong. Always double check. 1 vertex. Question 16 involves a cumulative frequency graph and a histogram. To find the median for 400 plants, we look for the height at the 200th plant. The graph shows that at a cumulative frequency of 200, the height is 30 centimeters. The interquartile range is the difference between the upper quartile at the 300th plant and the lower quartile at the 100th plant. 80% of 400 is 320. Go across from 320 to the curve, then down. From the graph, at a height of 60, the cumulative frequency is 360. This means 360 plants are 60 centimeters or shorter. Now, let's look at the histogram. Frequency density equals frequency divided by class width. Interval 20 to 30. Width, 10. Frequency, 80. Density equals 80 divided by 10, which is 8. Interval 30 to 40. Width 10. Frequency 124. Density equals 12.4. Interval 40 to 80. Width 40. Frequency 76. Density equals 1.9. Common mistake, drawing the heights as the frequency itself. Remember, in a histogram, the area represents frequency. Question 17 focuses on circle theorems and similar triangles. For a cyclic quadrilateral, we use the property that angles in the same segment are equal. Angle BDA and angle BCA both subtend arc AB. Since angle BCA is 34 degrees, angle BDA must also be 34 degrees. Opposite angles in a cyclic quadrilateral sum to 180 degrees. Angle BCD is equal to 180 minus angle ABAD. Angle BCD is equal to 180 to 74. The answer is 106 degrees. Let's look at the angles subtending the same arc again. Angle ABD and angle ACD subtend arc AD. We know angle BCD is 106 and angle BCA is 34. Angle ACD equals 106, 34, which is 72 degrees. Therefore, angle ABD is also 72 degrees. Triangles ADX and BCX are similar. This means the ratio of their corresponding sides is constant. The ratio equals AD over BC, which is 9 over 4.5, resulting in 2. The side AD is twice as long as BC. Therefore, all sides in triangle ADX are twice as long as the corresponding sides in triangle BCX. The corresponding side to XD in the smaller triangle is XC. XD equals 2 times XC. XD equals 2 times 3.3. The final answer is 6.6 centimeters. A common mistake in similarity is pairing the wrong sides. Always check the angles to ensure you are comparing corresponding sides. Question 18 involves functions, composite functions, and inverses. F of x equals 3 minus 2x, g of x equals 2x plus 3, and h of x equals 2 to the power of x. For part AI, find f of negative 3. F of negative 3 equals 3 minus 2 times negative 3. 3 plus 6 equals 9. For part A, i.e., find gf of negative 3. This means we take the result of f of negative 3, which is 9, and plug it into g. G of 9 equals 2 times 9 plus 3. 18 plus 3 equals 21. In part B, we find the inverse of f. We start by writing y equals 3 minus 2x, then swap x and y. Rearranging, 2y equals 3 minus x. So y equals 3 minus x over 2. The inverse of f of x is 3 minus x over 2. For part C, find x when gg of x equals 7. First, find the expression for gg of x. Expanding gives 4x plus 6 plus 3, which simplifies to 4x plus 9. Now set this equal to 7. Subtracting 9 gives 4x equals negative 2. Dividing by 4, we find x equals negative 0.5. Finally, part D, find x when h inverse of x equals 5. This is equivalent to saying h of 5 equals x. X equals 2 to the power of 5. So x equals 32. A common mistake in part D is trying to find a formula for the inverse, using logarithms, which isn't necessary if you understand the relationship between a function and its inverse. Questions 19 and 20 involve surds and variation. Question 19a. Simplify the square root of 32 plus the square root of 98. To simplify surds, we look for the largest square number that is a factor. This simplifies to 4 root 2 plus 7 root 2. Adding these together gives the final answer, 11 root 2. Question 19b. Rationalize the denominator of 1 over root 2 plus 1. To rationalize a binomial denominator, we multiply the top and bottom by the conjugate, which is root 2 minus 1. The denominator becomes root 2 squared minus 1 squared, which is 2 minus 1. So the final answer is simply root 2 1. A common error is multiplying by just root 2. That only works for single-term denominators. Question 20. Y is inversely proportional to the square root of x. We start by writing the equation y equals k over the square root of x. Substitute the initial values y equals 8 and x equals 4 to find k. This simplifies to 8 equals k over 2, so k equals 16. Our formula is y equals 16 over the square root of x. Now we substitute x equals 49. This gives y equals 16 over 7, which simplifies to 2 and 2 sevenths. Leaving the answer as 16 sevenths is also perfectly acceptable. Question 21 combines geometry with algebraic manipulation and quadratic equations. Part A. Expression for the height of the rectangle. We are given that the height of the rectangle is h plus 2. However, the question asks for an expression in terms of x. We know the area of the rectangle is 30 to 9 and the length is x plus 1. Area equals length times height. 39 equals the quantity x plus 1 times the quantity h plus 2. So we can express the height, which is h plus 2, by dividing the area by the length. The answer is 39 divided by the quantity x plus 1. Part B. Show that 2 times squared minus 15 times plus 20, 2 equals 0. Now we look at the triangle. Its area is 11, base is x, and height is h. Area equals 1/2 times x times h, which equals 11. This simplifies to xh equals 22, so h equals 22 over x. From part A, we know h plus 2 equals 39 over x plus 1. Let's substitute h. 22 over x plus 2 equals 39 over x plus 1. Multiply the entire equation by x and by x plus 1 to clear the denominators. We get 22 times the quantity x plus 1 plus 2 times the quantity x plus 1 equals 39 times. Expanding gives 22 times plus 22 plus 2 times squared plus 2 times equals 39 times. Simplifying, we have 2 times squared plus 24 times plus 22 equals 39 times. Subtract 39 times from both sides to reach the final equation. 2 times squared minus 15 times plus 20 2 equals 0. Part C. Find the two possible heights of the triangle. First, factorize the quadratic. We need numbers that multiply to 44 and add to -15. These are -4 and -11. The factors are the quantity. 2 times minus 11 times the quantity x minus 2 equals 0, so x equals 5.5, or x equals 2. We need to find h, where h equals 22 divided by x. If x equals 2, h equals 22 divided by 2, which is 11. If x equals 5.5, h equals 22 divided by 5.5, which is 4. The answer is h equals 4, or h equals 11. Remember, the question asks for h, not x. A common mistake is stopping once you've solved for x. Questions 22 and 23 cover trigonometry and algebraic fractions. We have a right-angled triangle with a 30-degree angle, an adjacent side of 8 centimeters, and a hypotenuse x. We use the cosine ratio. Cosine of 30 degrees equals adjacent over hypotenuse, which is 8 over x. We need the exact value, so we must know that cosine of 30 degrees is square root 3 over 2. Multiplying across, we get x times root 3 equals 16. Then x equals 16 divided by root 3. To simplify, rationalize the denominator by multiplying top and bottom by root 3. A common mistake here is using the wrong ratio, like sine, or using a decimal for cosine 30. Exact value always means no decimals. Question 23 asks us to write 3 over x minus 4 over x plus 3 as a single fraction. To subtract fractions, we need a common denominator, which is the product of the two denominators. Expand the numerator. 3 times x is 3x, 3 times 3 is 9. Then -4 times x is -4x, and -4 times -4 is positive 16. Combine like terms. 3x 4x is -x, and 9 plus 16 is 25. The final answer is 25 minus x over the product of x, 4 and x plus 3. Watch out for the signs. When subtracting the second term, the minus applies to the whole numerator, so -4 times -4 becomes positive 16. Questions 24 and 25 deal with completing the square and similar shapes. Write x squared minus 4 times plus 7 in completed square form. To complete the square, we take half of the coefficient of x, which is -2. x2 squared equals x squared minus 4x plus 4. We have a plus 7, so we need to add 3 to the expansion. The answer is x2 squared plus 3. Find the turning point of y equals x squared minus 4x plus 7. The turning point is easily found from the completed square form. The x-coordinate makes the bracket 0, and the y-coordinate is the constant at the end. The coordinates are 2, 3. Find x for two mathematically similar hearts. We are given the area of the larger shape is 36, and the smaller is 25. The area scale factor is the ratio of the areas. To find the length scale factor, we take the square root of the area scale factor. The height of the larger shape is 9. To find the smaller height x, we divide by the length scale factor. This is 9 times 5 over 6, which is 45 over 6. So x is 7.5 centimeters. A major pitfall here is using the area scale factor directly on the lengths. Always remember, lengths are scale factor k, areas are k squared, and volumes are k cubed. Finally, let's solve question 26, which involves sketching a cubic graph, expansion, and finding a tangent. To sketch this, first find the x-intercepts by setting f of x to 0. The roots are x equals 0, x equals -2, and x equals 3. The graph is a positive cubic, so it starts low on the left and ends high on the right. It will cross the y-axis at 0. Next, for part B, we expand and simplify the expression. First, multiply the brackets. This simplifies to x squared minus x minus 6. Now multiply by the remaining x to get the final answer. X cubed minus x squared minus 6x. Part C asks for the coordinates of B, where the tangent to A meets the y-axis. We differentiate the expanded expression. At point A, x equals 1. Plugging this in, the gradient m is 326, which equals -5. Now we find the equation of the tangent line, using y minus y1 equals m times x minus x1. Simplifying, we get y plus 6 equals -5x plus 5, which gives y equals -5x minus 1. Point B is where this line meets the y-axis, meaning x equals 0. So the coordinates of B are 0, -1. This concludes the paper. Well done on working through these non-calculator challenges.